All right. Jeff, stop it, dude. All right. So, this test is going to go back to confidence intervals, right? So we've got those formulas. So let's put those up here. We got, and don't forget, the beautiful thing about these formulas, hidden inside of them is a clue as to when to use t-scores. We still don't seem to understand. I always have to have some kind of standard deviation. So don't just say, I know the standard deviation. All right, so what? It's which standard deviation do you know, right? Yeah. So the formula, look, Z goes with sigma. The next formula is T goes with S. T goes with S. When into the sample standard deviation, use t-score. The formula tells you. You got to appreciate that. Right? And then, of course, you got the one that's for percentages with all the hats and stuff on them. I like it. So, do those look familiar? Some of you guys are like, did we talk about that? All right. And then you have the formulas for finding out how large of a sample you need to be within so much. So you got this little dude and this little dude. What do you use if you don't know P hat or Q hat? If you don't know a percentage, your best guess is 50-50. Yeah, 0.5, 0.5. That mathematically makes n the biggest, and why does it make sense? Because if I don't know, it should be the worst for me. If I don't know something, I should have to take the largest sample I would possibly have to take, because I don't know something. Okay. So that's confidence intervals. I'm not going to let you write down ideas like, what tells me I'm allowed to do this, to use a z-score with this? What would I have to check? So I have to check for normality. How would I do it in this case? N bigger than 30? No.
Greater than 5.
What about greater than 5? What's greater than 5?
NP.
NP and NQ. In this case, NP hat, NQ hat. Like, do you remember that? A little bit. I'm pretty nice and I say check NP and NQ. Right. So notice I say normally, so we'll see what happens on this test. All right, and then we go into hypothesis testing. And really, there's no real new formulas at first until we hit, the first really new formula with hypothesis tests. So if you want to, you can write down this stuff. This is old news. And just to remind yourself, you can even write down, you got to do this no matter what. Even if you have a sample standard deviation, you still have to change it into one that works for groups. Right? When you do this, you don't make it into a sample standard deviation. You make it into a standard deviation that works for groups. So you've got to always do that when you're taking a sample. Okay, cool. So that's old news, but we're using it in the hypothesis testing. So if you want to put it right there, it makes sense. The new ones, can you close that door? Thanks, man. The new ones would be like this guy here. All right, see how we stole this? That's the standard deviation. See, that's in the right place to be the standard deviation? So we stole it and used it over there. There's no hats on them, because in this case I know the population percentage. I'm assuming that I know it. Okay. No looks of recognition, but I'll be okay. I'll get over it. All right. And then we've got the mammoth ones, right? The ones that have room for 2 samples. The double wide. I like that. It's just for me, I guess. Come at 2. Well, I'll put what happens most of the time. We don't know sigma, but if we do know sigma, then of course I would use. You could put T if you want to, just to really reinforce that, right? T's go with S's. So is there anything I've forgotten that you think of? Make sure this can see the whole thing for people at home.
What is E again?
Yeah, what's E mean?
Error.
Error. So if the problem says I want to be within 3%, what would you put down here? 0.03. So that word within, 90% of the time they're going to use the word within. Sometimes they'll say something dumb like, I want to be off by or something. But the word within is a big key that's the error. I want to be within 4 inches. So you're going to put 4 here in E. Cool. That's your error. So where's the error in these formulas? This piece, right? This piece. This is the give or take. I think it's this, give or take, how much I think I'm off by. So we mark really enough math people said, let's call that the error. Right? Because that's how much we think we're off by. Okay, cool. Alright, so anything else? You guys are like, dude, I forgot half of those. What do you want from me? Yes?
What about the Z star for the not proportion problem?
Oh, I forgot, how do you mean? Oh, that's this. You can put a little star there if you want. My bad. Yeah, you can put a little star there. The other one I forgot was the Z star for the 2 proportion ones. So you guys are like, whatever, man. Put it up there. Alright. So just like this guy would be for 2 proportions. P hat 1, P hat 2. P bar, Q bar. P bar, Q bar. So what the hell's P bar and Q bar? What's P bar? Oh shit. Well, P bar is the total successes over the total people or whatever. All right, that's where we say, why are we dividing people up? Let's put everybody together.
So we can write that down.
Yeah, totally.
Okay.
That's fine. That is a formula I am happy to let you write down. So again, if I'm you, I would collect all my worksheets that I've gotten that have all these formulas on them, double check, make sure I got the right ones written down. If you find a formula between now and the test time, you can just show me before the class and say, could I put this on my formula sheet? But all of these are about how far something is from some accepted middle. That's the whole idea of hypothesis test. How did I get far enough away with my sample to say that this looks wrong? That's the hypothesis test. That's it. Now, of course, to work it out, there's a few steps. But the idea of it is that's it. Take a sample. Did you get far enough away to make it look like that's wrong? That's the heart of the hypothesis test. Okay. All right. Any other formulas that you can think of? Anybody have a suggestion? All right. Any questions? Where do you want to go first?
The practice test?
Sure. Did I keep some for myself? That would have been nice, Jeff. Yes, I did. Okay.
Can we do number 3?
Oh, yeah, okay. All right. So you got to know that I'm going to give you a problem where you have to calculate your own statistics. You have to calculate your own X bar, your own S, using the 1-bar stats in the calculator.
Yeah.
Calculator.
Yeah.
So I'm going to go through that with you for the people that passed the class in this problem. So really, this problem is asking you to create 2 confidence intervals. Now, when we first talked about confidence interval, we constructed a few of them, and then I started to ask you, does this show evidence that it could be this, or it's more than that? So confidence intervals are sort of a crude test. Hypothesis tests are the ones that are accepted to be real tests. But a confidence interval is quicker, and it gives me an idea about what things really are. So it sort of gives me some evidence. Yeah. So let's see. Maybe I should point you that way. Okay. So if we take this data for number 3 for the people that passed the class. I can't remember if this is real data. I think this is related to real data. Oops. Stat. So right there's your stat button. Edit. So that's where you can go in your list. I'm just going to clear this first list. Well, you can clear several out if you want to. Go. So we stop right there. Is everybody that wants to play along right now got that showing up? If your lists ever freak out, so I can't remember this calculator let me do this. Oh shit, L1 is gone. It's gone. See how L1 is gone? That sucks. So that if that ever happens, so you just hit stat, setup editor. Bam. Oh, I had to emphasize that. It's very anticlimactic, actually. Done. And then it'll make sure it's L1, L2, L3. So if you borrow a calculator from somebody and who knows what somebody did with it before you, they could be freaky. They could be called Frank, Bob. There's ways to rename them. You're like, I don't know how to find the mean of Frank. I don't know. So put in here the people that passed the class, so 7.1, 6.5, 8.3, Jeff. All right. Yeah, there were 16. A really good check is to make sure that the last filled in spot matches with how many is in the list. So you didn't just forget somebody, right? You could also forget a decimal, but if your average for this data came out to be 11 and you just start doing the problem, that is troublesome. Part of what this class is supposed to teach you is how to kind of tell when, would a mean of 11 make any sense? Why not? There's 11 is bigger than all of them. How could that be the average, right? So you should be able to tell when you have a major mistake like that. Mean can't come out negative because I don't know what that means. They anti-studied, right? There's a negative average hours. I don't know. Think about it. So how do I get the mean and the standard deviation? Now we got them all in there. Stat. Calc. I want to calculate something. 1 bar stats, because they only put 1 bar in there, 1 variable. Now, if you have the older one, it'll just go straight to this. If you have the newer one, it'll say something like your list, make sure it says L1. Frequency list, leave that blank, and then calculate. At this point, if you have the newer, you should be used to that. Older ones just say, all right, do it. So is that what everybody got?
Yeah.
Alright, so we're all wrong. No, I'm joking. This is fine. Okay, so what am I going to have to use? So you're going to do the same exact thing I just did for the list of people that failed the class and get their own mean, right? And I think some of you guys know the point I'm trying to make, the same point I've been making the whole semester. But anyway, how would I construct a confidence interval off of this then? What am I going to pull? What's the only stuff in here that's applicable to this problem? X bar and S, exactly. Why did it tell me this? Why did it give me hope that I could use Z-scores and stuff?
It's a trap.
Exactly. I was hoping you would bring them. Because the calculator doesn't know if it's a population. I know it's a sample, so I have to discard this as the human in this situation. I have to know to get this. It's a sample I'm working with. Do you guys understand? That's why it gives me both. It's not tripping me up. Now, that's a little too blatant, right? Computers trip us up a little more deceptively. That would be a little too blatant. It's just give me both just in case. So what am I going to have to use to construct this confidence interval then? T-scores. I love it. Especially because I actually told you in this problem that it's known that the populations are normally distributed. Cool, I like it. Is that okay, whoever asked that question? Is that what you really needed help with?
No, just what to do afterwards.
So
This
now
part was
that you
open.
know, now that we know X bar, we got the formula, right? You look up T, what's the degrees of freedom? N is 16? 15. So you look up 15 degrees of freedom. I want a 90, what was it? 95%? Yeah. I don't know if I have a T-score left with me.
And then you said that if we don't know the degrees of freedom, it's 0.05, right?
No, if we don't know alpha,
Alpha.
Yeah.
Okay.
but this is a confidence interval 95%, so alpha is 0.05.
Yeah.
And it's
How many tail tests is a confidence interval always?
2.
2. Because it cuts the middle off, it always makes 2 tails. So what T-score do you guys get? Say again.
2.131.
Yes, good. 2.131. I like it. So make sure you can get 2.131 as your T-score. Degrees of freedom was 15. Look at 0.05, 2 tails. Right there. 2.131. And then you just plug and chug. We know X bar. You put 7.63 here, plus or minus 2.131 times 1.146 divided by square root of 16.
Then what about the ones who failed the class?
Well, that's what we just did. That's the ones who failed, right? Or is that the one? No, that's the one we passed.
Yeah.
And then everything we just did,
Yeah.
you do it again for the ones who failed. You make
Okay.
their own confidence interval. I'm
Okay.
making 2 confidence intervals, and what am I really seeing? To see if they do what? To see if they overlap. If they overlap, they could be the same at 95% confidence. If they don't overlap, that's evidence that they're not the same. That's evidence that there's an effect of what I'm studying. It's evidence that the studying has an effect on grades. That would be ground shaking. Sorry. Stupid sarcastic teachers. All right. Yes?
So how would you know if it's 1 or 2 tails?
Confidence intervals are always 2 tails. I don't know if you remember when I first gave you the T-score chart, we had never heard of hypothesis tests ever. And we always looked at the second row, because when you make a confidence interval, how many tails do you make? 2. Because you go up and down, and you leave it's always 2-tailed test. It's not even a test, it's just always 2 tails.
Okay.
Right? But you can always use a Z-score chart instead. You know the old-fashioned way, or you get the little baby chart on the Z-score chart. That'll work fine. So, you're making me tired. Alright. How many of you guys tried that practice test? Anybody try it already? If you guys have. Let me go ahead and give you the answer key. Again, if you haven't tried it at all, don't even look at this, because you're going to get false confidence. Oh yeah, I would have done that.
So you don't have to use degrees of freedom with a lesser number?
No,
16 versus 14?
you totally do. Of course you do. Yeah, everything we just did, you do it again for the second group.
Right.
And we're going to get S from the second group, so we still have to use the T-score. So degrees of freedom for that second group would be 13.
13.
It's always N minus
Right,
1.
it's not, you don't use the same one for both.
No, because they have different sample sizes.
And then what formula do you use?
Yeah, that one. It's got me. It's the same because I'm doing the same thing just for 2 different groups. I didn't end up putting number 7 on here for 2 reasons. 1, I ran out of room. 2, I ran out of time. So if you're curious, I'll do that towards the end of class. I'll show you real quick how to get that started.
Number 7.
It would only be as a bonus because I made the section exercise.
I know, that was
so
the one
sometimes
I
I
was
put
like,
bonus
oh,
questions related to that.
I just totally just started studying. You look and agree.
What's up?
Looking and agreeing.
Oh yeah, exactly. It's an easy. It's a trap. Ooh, oh boy.
So in number 5, you're just doing mean 1, 3, and 2.
Yep. I don't know why in number 5 I made my sample have a 10.4 mean that makes the z-score so huge. I don't know. I keep Frankensteining these things together, and sometimes things like that happen. So, yes.
Quick question on that one right there. When you set it up, it's 7.63.
Here, let's do it. Everybody's got this here, right?
Yeah.
And we got an eraser. There. So let's see. We got X bar 7.63, give or take. The t-score was 2.131.
Yeah.
Times the standard deviation S divided by the square root of the sample size. Is that cool? Just plug and chuck. So sometimes I'll give you this in a problem, and sometimes I'll just give you a list of data. So you just take a second and you figure it out for yourself. But X bar goes here, S goes here. Look up the T or Z score.
If we rounded the 1.146 to just 1.15, is that okay? Or no? No.
No. Because standard deviation, I said you always have to have at least three places, yeah. Because that staves off too much rounding error. Basically, in any problem, you just don't want to round too much too early. Any rounding you do, you really want to do it towards the end. Right? Because any rounding you do in the middle of a problem just makes it worse and worse and worse and worse. It's like being 1 degree off in a boat. 10 hours later, you are somewhere. You have no idea. I don't know. I don't boat either, so I don't know if that made any sense to anybody. But oh well. It doesn't take that much. If you ever saw the movie Ice Pirates, they were only off by... No? Have you ever seen the movie Ice Pirates? Look it up. It's a kick-ass movie. Yes?
Can you do number 6? Because I'm not sure if we did proportions for 2. Did we? I thought we just did 3.
No, we did. Yeah, we did before. That's where the P-bar comes from.
Okay.
Yeah. Uh-oh. So what's up? You guys got any... I got a question for you. Look real quick at 4D on the back of the answer key. 4D. Where did I get that p-value from? What is a p-value?
You get it from the z-score sheet.
Yeah, so I got a z-score. My z-star was negative 3.05. The p-value is always the area and the tail or tails that your z-score makes. So you just got to look that up on the z-score chart. Get the p-value. Now for t-scores, you do need technology to get a specific p-value because our chart is nowhere near detailed enough. I don't know if you understand. Every single degree of freedom, if I wanted a detailed t-score, I'd have to have the size of the z-score chart for every single degree of freedom to have enough information to be able to do the same kind of things. I can't find the p-value for a t-score chart because our t-score chart is not detailed enough. It's only got very little information for every degree of freedom. The z-score chart is everything just about, right? Okay, maybe. So so if I find a sample that's this far down, the probability that that would have just had, I really want this to make sense because this is the heart of this. If this really was the true middle, whatever the situation, that really was the true middle, then how often would I find something down here? About 0.11% of the time. If that is the real middle, I would get down here 0.11% of the time. Is that something that will happen a lot? And we just did it. We did this once, and we just did it. It's like going into a casino and going, yeah, I'll try to win this $2 million. You won. Holy shit. Okay. That would be insane. And this person over here is like, I've been here all day. Damn you. So that would be insane. Wouldn't it be insane? So we did this one. We did once, and we got the lottery. We won the lottery. No. What's more likely then is that's not really the middle. The middle is probably more down here, which makes what we did less unlikely. Alternately more likely, right? Because that's the heart of it. So, assuming this is the middle, look what I just did. I just did something really unlikely, so that's probably not the middle. That's why we reject the null if I do this. It can't be there. It's got to be down here. That's what the hypothesis test is all about. There's always a chance we're wrong, because even though it's a very small chance, there's still a chance. There is somebody in history that has walked into, played a little stupid game, what do you even call them? You don't even have to do this thing, you just push the buttons. Just walk in and go, I've never done this before, let me try it. $15 million. That has happened at some point in history. It has, because it's less likely that it hasn't. Right? That's weird on its own, but oh well. But how often, so maybe one person in the last 100 years has happened for, so that is a remarkably small chance, but it could still happen. We could be wrong, that's the chances I'm wrong. I can live with that shit. That's better than normal for me. Okay. Try it. So where do you guys... I was going to say, where do you want to go? I think I know the answer, but where do you want to go statistically? Where do you want to deal with? Yeah.
Is there any way you would have a question like that would give you both like your sigma and the S, and also ask you for the population mean, even though they only give you a sample? Like in chapter, like a bit behind, but in chapter 8 they have one that says, like it gives you a sample amount of bags or whatever, but then it also gives you your sigma and a sample mean. Then they're asking the question for a confidence interval of the population.
Well, that's what a confidence interval does. I don't know what the population mean is, but based on my sample, I can say with so much confidence that this interval catches it.
So you do use sample mean.
Yeah, you have to use the sample mean. It's the only thing I got. Now, if I know, all right, I really want this to make sense. When can I use z-scores?
If they just give you the whole thing.
When can I use z-scores? If I know the population standard deviation. Every time I take a sample, can't I calculate an S, a standard deviation?
Yes.
If I knew sigma and I calculated S, because some of the book problems, they give you both. Because you can calculate S every time you take a damn sample, but would you use the damn thing? No, I'm going to use a freaking sigma. That's the more powerful thing. I'm going to use that bad boy, right? So it's a little evil to give both, but that's what could happen in reality. Now, if I was doing that, I wouldn't even calculate the sample standard deviation, if I already know what the population standard deviation is. But you use that if you got it. If you don't got it, oh shit, I got to use S. Oh shit, I got to use t-scores.
So your N would still be the number they give you, right? Even if it's just
The X bar, the mean?
not the N.
Oh, the N would be how big the sample was? Yeah. Now, let me just say this. If this might seem silly, because I always get this comment about I give way too much homework. So if you think the homework is too much, don't just not do any of it. I've had this discussion with you guys before. Do some of the problems. It's all about practice. That's why I signed what I did, because I thought that was enough for you to really kind of get all the ins and outs of the problems. But if you don't do any of it, it doesn't make any sense. So don't just not do it because I'm never going to finish that. Well, then don't finish it. Do some. You're doing something for yourself to get ready for the test. Don't do it for me. Screw you, Jeff. No, then just do something for yourself. Sorry, I'm trying to make that message better and stronger, because the homework thing just kills all teachers. No teachers understand it. Because I was a geek when I was younger, so I still know. I can't relate. Of course I'm going to do the homework. It was assigned to me. Of course I was going to do it.
Can you do number 7?
Well, I wanted to put that towards the end, since it's going to be bonus. I want to make sure we hit the substance of it first. But, if nobody has any questions, then yeah, I could do it. Which one?
After the conclusion.
So yeah, that kind of bugs me. That's the one I was talking about that I wish I hadn't changed some of these numbers at some point in history. Let's see if this actually works here.